Here is the visual representation of k-means clustering applied to a set of two-dimensional points. So first, we generated 100 random points in a two-dimensional space, which represented by the two different colors, which corresponding to different clusters. And we specified k equals 3, thus the data points are grouped into 3 clusters, cluster 1, cluster 2, and cluster 3. Each cluster's centroid is marked by a white X, so these centroids are calculated as the mean of all points in the respective clusters and are used to determine the cluster membership of the points during the iteration of the k-means algorithm. So this clustering is very practical example of how can we partition a set S of points into k disjoint clusters. And well, each cluster group's points are closer to each other than to points in the other clusters, so thereby we can achieve the goal of k-clustering algorithm. We just explained the concept of k-clustering for a set S of n points in d-dimensional Euclidean space, and this scatter plot representing a set of points in two-dimensional Euclidean space. Then we applied a clustering algorithm like k-means algorithm to divide these points into k-clusters and visualize these clusters by using different colors. Here we have a high k values, which is k is equals 10 for clustering a data set that visually consists mainly of one major clusters and a few outliers. So the purpose was to illustrate the potential for empty clusters when the number of defined clusters exceeds the natural groupings in the data. So most of the centroids which have landed near or within the main cluster, and some centroids are closer to outliers, which are attempting to form separate clusters around a single or very few points, and some centroids are isolated without any nearby data points. So these represent empty clusters where there's no data points were assigned during the k-means process. So this occurs because the number of centroids exceeds the variety in the data spatial distribution. These centroids try to position themselves where they can minimize the distance to the points assigned to them. So in this case, with an extensive number of centroids, some may end with isolated if there are not enough distinct groups of points to form meaningful clusters. So not all clusters have data points. This inefficiency indicates that the chosen k is not optimal for this particular data set, right? So this example highlights why selecting an appropriate k value is crucial in k-means clusterings to avoid any inefficiencies and ensure meaningful cluster information. So this phenomena of empty clusters particularly emphasizes the need for some techniques like L-bond method or cellular analysis to determine an optimal k before we apply any k-means. We just discussed about how a cluster with a k-clustering setup may be empty, and we emphasized the k-clustering can be defined in terms of the centers of these clusters. And then we visualized the example where we have a scenario with potential empty clusters. So this could happen if we chose a number of cluster k exceeds the number of distinct groups which is formed naturally by data points. For instance, if we're choosing a k value larger than the necessary for a given data set where all data points are identical or extremely closer together, which will result in a fewer distinct clusters than k. So according to this generated 2D data set, most points cluster tightly in one area with only very few outliers. And then we applied k-means clustering with a k value which is larger than the number of natural clusters visible in the data. So this can lead to one or more empty clusters, which we try to identify and visualize here.